Good afternoon, it's Engineer Heather there. I warmly welcome all of you guys on my channel Complex World. So this is the lecture number 4 of our calculus on the topic of functions and graph. So today we are going to solve some practice examples on functions and graph. So we are given with an example. So in this example, Daniel leaves his house at 5:50 a.m. and goes for a 9-mile run. He returned to his house at 7:08 a.m. Describe the distance d in miles Daniel run as a linear function of his run, which is the function of time t. Intercept the meaning of a slope. So you are given in this question with the time that he start his running at which time and the time of returning of his to his house. You have to find the distance or describe the distance in miles, and you are supposed to intercept the meaning of the slope which you have calculated in this question. So you can see in the question that we are supposed to sketch the graph first for this statement problem. So we all know that in my first part I have clear each and everything about the dependent and independent variable. So time is an independent quantity, so time does not depend upon anything. So the time comes on x-axis. Time is an independent variable and the distance depend upon time. So at time t equals to 0, Daniel is at his house. So at t equals to 0, it's 0 distance. Daniel covers 0 distance when the time t equals to 0. So calculate the minutes from 5:50 to 7:08. You will get t of 78 minutes. He run for 9 miles. So what would be our equation for slope? We all know that slope equals to y2 minus y1 over x2 minus x1. In this case, what would be our point like? So the first point would be for x1 minus x1 y1, and the second one is x2 y2. So for x1, what would be the value for x1? X1 would be 0 because the initial starting point of the Daniel was 0, so x1 would be 0. y1, what is the value for y1? When the time is 0, the distance also 0. For x2, we know that the time is 78. X is for time because x is on x-axis there is a time quantity, and for y-axis we have the distance here. For y2 we have 9 miles. So put these two values in that equation. y2 minus y1 over x2 minus x1. So you will get the slope 9 by 7. So our slope is 9 by 78. So this is the answer for the first part. Describe the distance as a linear run for the function of time. So this is the answer for this case. You have to find the slope. Okay. The second part is intercept the meaning of a slope. What is the meaning of that slope? It's a slope. We all know that slope is the change in distance on y-axis to x-axis, mean delta y divided by delta x. Change in the points on y-axis divided by change in the points on x-axis. So the points change on y-axis is 0 to 9 miles, and the point change from on x-axis is 0 to 78 miles. So our point will be at 78 minutes, it's 9 miles. So our point is at this point. So the meaning of that slope, when you divide this one, you will get some point answer. This means that the Daniel cover that distance in 1 minute. Okay, now come to example number 2, which is an example of function that you are in this question. You are given with two functions, f of x and g of x, with the values f of x equals to 2x square plus 1 and g of x equals to x plus 1, and you are supposed to find the f of g of x and g of f of x. So in my previous lecture, in the lecture of the functions, I have clear each and everything that how to calculate and find the values of these type of functions when you are given with two functions. So let's start with the first part, f of g of x. In this case, you have to put the value of g of x in the function f of x. So f of x equals to 2x square plus 1. So you have to find f of g of x in that case. So put the value of g of x in f of x. In that case, you will get the answer for f of g of x. So g of x equals to x plus 1. And you have to put x plus 1 in that x to find the f of g of x. 2 into x plus 1 whole square plus 1 Okay, now open the square of this bracket. You will get the answer 2 into x square plus 2x plus 1 and this one. Now multiply 2x square plus 4x plus 2 plus 1. 2x square plus 4x plus 3 is the answer for f of g of x of this equation. Okay, now find g of f of x. How to find the g of f of x? G of f of x, you have to put the value of f of x into g of x. So g of x equals to x plus 1 and f of x equals to x square plus 1. So you have to put this value in x. You will get the answer 2x square plus 1 plus 1. So you will get 2x square plus 2. Take 2 common, x square plus 1. So this is the answer for g of f of x. Now come to the next topic, which is the shifting in the linear function. That what is the shifting in the linear function? So you all know that the equation for the linear function is y equals to x. So this is the equation for linear function. You can put any value in the x minus infinity to positive infinity and you will get the range minus infinity plus infinity. In the you will get the straight line you will get the straight line for this function. We all know that this is a linear function. So what will be the shifting theorem say, or what is the shifting in the linear function? So let's say our equation is y equals to x plus 1 and y equals to x minus 1. When you are adding or subtracting something from the equation, this is known as the shifting value of the function, and this will change or shift the graph of the linear function to that specific value. So let's sketch these two graphs first. Okay, let's sketch the graph for the first equation y equals to x plus 1. When you are going to sketch the graph for that equation y equals to x plus 1, you have to construct the table first, in which you are supposed to assume the values for the x and then put these values one by one in the equation to get the values of the y. So I am taking the value from -3 to +3 and one by one I am going to put these values in that equation to get the values of the y for sketching of my graph. So when you put -3 in the equation, you will get the answer -3 plus 1, you will get -2. And when you put -2 in that equation, you will get -2 plus 1 -1, and when you get -1 in there, you will get 0, and when you put 0 in that equation, you will get 1, and when you put 1, you will get 2, and when you put 2 in that equation, you will get 3, and when you put 3 in that equation, you will get 4. So these are the points on the y-axis. Now we have to sketch the graph on these points one by one. So when -3, you have the answer -2. At -3 we have -2. Okay, at -2 we have -1. This is the -2 point and this is the -1 point. We have this one, and at -1 we have 0, and at 0 we have 1. Sorry, this is the point, this is not the point. Okay, at 0 we have 1, this is also not the point, and at 1 we have 2, and at 2 we have 3, and at 3 we have 4. So you will get the graph of a straight line. So you can see in that graph that our graph is shifted at this point. When there is no shifting, the graph is passing through the point 0, but when there is a shifting of +1, the graph is shifted at the point 1. This is +1. So you can see the shifting of that graph when there is adding or subtracting of some kind of number from the equation. The graph is shifting at the point +1. So same is the case with the -1. When you put that value, this is your home task. You can practice this one same like this, and you can see the shifting of a graph at the point -1. +1 and -1, you can see the shifting. So this is the shifting in a linear equation, linear function. When there is a function which is a quadratic function, now what is the shifting be like in a quadratic function? Same is the case with the quadratic function. We all familiar with the parabolic shape is the graph of quadratic function y equals to x square. So what will be the graph like for x equals to y equals to x square plus 1 and y equals to x square minus 1. So this is also your home task, to practice the shifting of the graphs by putting the values of the x one by one and to get the values of y one by one, and then sketch in the graphical paper or rough graph. You can see and you can